Hello and welcome to the next episode in our video series, and I want to start a new mini-series about the implicit association test, and today I'm going to talk about how it works and what you can do with this. In the next videos, if you like them, at least if people demand them, we will talk about how to develop one using the two tools that I'm usually using for the implicit association test. And if you think about the implicit association test, it is meant to measure your stereotypes or prejudices or associations, implicit associations, because actually it is the same. In the event of a stereotype, for example, we talk about, the cats and dogs, we implicitly associate them with something. We have a kind of prejudice or stereotype. And let's assume that if we talk about the cats, we think they're cute. If we think about the dogs, we think they're ugly. I, of course, disagree with this because I have both a cat and a dog, and I think they're both cute, but at least at our university, one of my colleagues, he makes a test with people who are cat lovers and dog lovers, and this test can actually help you understand whether your participants are dog lovers or cat lovers. And it works as following. Try now my mouse. Yeah, it seems to work. And I want that we make a thought experiment. I'm going to show you pictures of cats and dogs. And each time you see a cat, you can shout cute, or you can give me a thumbs up. Just try it while I'm going to show you the pictures, just showing with the hand a thumbs up. Or if you see a dog, you have to show thumbs down, or you can shout ugly. And we try to do it as fast as possible. I'm going to show the pictures and you try to respond immediately, either with a thumbs up, thumbs down, or you can shout cute or ugly. Nobody hears to you, you are listening, you are watching YouTube, so probably you're alone in the room. Let's try this out. So, and now we're going to do the following. We are going to run through the same task, and after you have voted, I want you to vote again. But this time, if you see a dog, you have to shout cute, or you have to give a thumbs up. If you see a cat, you have to shout ugly, or you have to show a thumbs down. And again, try to be as fast as possible. Let's try it. And as you have seen, I showed only a few pictures, but the main idea is that we can test your stereotype. It means how fast do you relate cats to cuteness, or cats to ugliness, and dogs to cuteness, or dogs to ugliness. Because if you have a stereotype, then theoretically this will be a connection that will come to your mind much faster. That is why you theoretically should have responded faster to something. For example, associating cats with cuteness, then associating dogs with cuteness. And this is what we want to do, because if you're faster in associating cats with cuteness, then you have a kind of stereotype. You need much fewer time to associate a cat with cuteness than a cat with ugliness, or a dog with cuteness and dog with ugliness. So theoretically we can check whether you're a dog lover or cat lover, and if you have a stereotype, then the implicit association will be there, it will be stronger, and that is why you will differ in the speed of your response, showing thumbs up or thumbs down, or shouting ugly or cute. And this is actually the main idea of the test, that theoretically, if I'm going to show you different pictures or words and asking you to associate them with each other and look at the speed of your response, then I can understand whether one of the associations is stronger than the other one. So again, similar to a discrete choice experiment, the implicit association test is the comparative test. We don't know all the stereotypes that you have, or the strength of the stereotype, because we can only compare the stereotype A against the stereotype B, that cats are associated with cuteness or dogs are associated with cuteness. And which of these two things you associate in your mind faster, it means that you have a stronger implicit association. So what is important to know, that really you compare only two categories, for example cats and dogs, with only two levels, cuteness or ugliness. And it poses some limitations on this test, because you have to know your stereotype, your specific stereotype, in advance. And it is not about a stereotype of one person, because the test makes, of course, for each person separately, you can search for the data for one specific person and see whether this person, she or he, has the stereotype against dogs or against cats. But actually what we're interested in testing, let's say 100 people, and look what is the average stereotype. And we had several of these tests, and I think one of the most famous tests is the one run by the Harvard Business School. And you can find it online, it is still running, and they test for the racial stereotype. And they do it in a way that they show you the pictures of Afro-Americans and Caucasians, and they ask you to associate them with words. And the words should be positive words or negative words. And then they see whether you are associating implicitly, let's say, Caucasian people or black people with a certain type of bad or good words. And this study runs, and I can tell you, because I ran several studies not on racial stereotypes and different other stereotypes, that the stereotypes, they may change over time. And you can specify a research question if you want to make research using this test with regard to the stereotype in a specific age group or profession, for example, that you would like to associate. You want to test the bank tellers, whether the bank tellers, they have some prejudices with regard to the clients, whether they treat different clients differently, for example, male and female clients, whether they associate them with more security or less security. So the test is about the two groups of people, and you can, or two groups of whatever you want to associate. It can be people, can also be cats or dogs, can be different other objects. And you can use both words or pictures. You can use words with words, pictures with pictures, pictures with words. In the terminology, if you develop an implicit association test, or if you want to work with an implicit association test, then you have the target. These are pictures or words. Your domain of investigation, for example, your domain of investigation are pets and their associated stereotypes. And the target A would be the dogs and target B would be the cats. And you have the attributes, the words that you want to associate them with. For example, the positive attribute, we call it positive attribute, although it's not about the positivity or negativity. So the positive attribute would be in this event cuteness, for example, cute, adorable, beautiful, charming, pretty. And the negative attributes would be the ugliness, and the words would be, for example, ugly, awful, beastly, gruesome, dreadful. And for this test, you will need these sets of words, or you will need sets of pictures and sets of words. And in the next, I'm going to show you how you can find these pictures and how you can find these words and how you can build an implicit association test. Today, we talk about it in theory. In one of the next episodes, we are going to talk about the software and how you can run an implicit association test. So the target and attributes, what should you use, pictures or words? It depends on the level of abstractness of your concepts, because if it is an abstract concept, then it's better to use words. If it is something concrete, then it's better to use pictures. So if we talk about the cats and dogs, it is pretty concrete. That's why you can use the pictures of dogs and cats. If we talk about the good and the evil, it's very hard to find the pictures for good and evil that will be the good and the evil for everybody, because different people will associate something different with good and the evil. That is why in this event it's better to use words. The targets, cats and dogs, can be also flowers and insects, males and females. They're easy to depict, as you can imagine. And the words like stress, for example, levels of stress, or the emotions, or the risk management, we talk about the risk. It's very hard to depict, find a picture for something risky. There will be pictures that are mostly associated with riskiness, but again, it's very hard to find. That's why it's better to use words. The same relates to uncertainty, to threats, dangers, and so on. So it's better in this event to use words. Before you run your test, you have to show the pictures in advance, what people will see, at least that they understand that this will be, okay, with a dog and with a cat, it's pretty simple, because everybody knows how a dog and a cat look like. But if you use, for example, as we use in our research, true and fake smiles, you have to show what is the true smile, what is the fake smile, to reassure that your participants understand what is the difference between those. This is an example. For example, this is the pictures from Manera et al. From their paper. I contacted the researchers and they sent me the pictures that they use in their research, and we use these pictures in one of our tests. And as you can see, you have the true smile. This is the one with action unit. I think it's action unit 10 that is activated here, and we don't have it here. That's why it's a bit different here. This muscle's a bit different here. That's why we can say that the one is a true smile and the one is the fake smile, what we see here. That's why it's better if you introduce these pictures in advance that people know what you are talking about. With regard to conditions, we have the targets, we have the attributes. So in our experiment, we looked at the target, which were cats and dogs, and the attributes were cuteness and ugliness, and we used them as positive attribute. I used cute. As negative attribute, I used ugly. But again, it's just the terminology. It can be different other words that you can use. We use the high control, low control words. We use the certainty, uncertainty words, and you just put them as positive and negative attribute. What is important, you have to understand that in your experiment, you have to assume what is your congruent condition and what is your incongruent condition. Again, it is just a matter of definition. We can assume that the congruent condition is that cats are cute and dogs are ugly, and the incongruent condition would be cats are ugly and dogs are cute. That's why I depict with the green arrows the consistent or congruent condition, and with the red arrow I depicted the incongruent or the inconsistent condition. Again, just a matter of your definition. You can use it vice versa. It's just important for the interpretation of the results, because the values will be, if they are positive, then actually the congruent condition holds. If they are negative, then the incongruent condition holds. If you change the conditions, nothing will matter, just the in the interpretation, just easier to understand what it is to know what is your congruent condition, what is your incongruent condition. And it's really up to you how you define it. And at the end, we produce the D-scores in most of the experiments. Theoretically, the most obvious thing that we produce are the milliseconds difference, because if we run this test over several trials, and we usually run it in 5 or 7 trials, depending on what kind of procedure you select. And in the first trial, you just show your targets. People have to look at the pictures of cats and dogs, and they have to sort them. As we did now in the presentation, you had to shout or you had to give me a thumbs up, thumbs down. In this experiment, usually you see a picture on the screen and you have to sort it. To the left with the letter E, if it is, for example, target A, if it is a cat, and to the right with the letter I on your keyboard, if it is your target B or the dog. And it's pretty easy. It's really about the milliseconds. You are shown with the pictures of cats and dogs, and you have to press E or I depending on where you sort them. And in the second trial, you are provided with the attributes, with the words related to positive or negative attributes, for example, the cuteness and all the words that we associate with cuteness, and the words with ugliness, you have to sort them again. If you see the word related to ugliness, let's say to the left, if you see the word related to cuteness, to the right. Then comes the important trial that you will actually need. You will be provided with the pictures and the words, and you have to sort them. If you see a cat or a positive word, then a positive attribute to the left. If you see a dog and the negative attribute or the ugliness, to the left. And then we have the fourth trial where we do it one more time. You have to sort the cats and dogs, but this time you have to sort the cats to the right and dogs to the left, just to you learn that things can be sorted differently, that you don't have this pre-trained effects. Each time you see a cat, you press the left button, so you have to learn to press also the right button for the cat. And then comes the fifth trial, and in the fifth trial you are shown the pictures and the words, and now it is if you see a cat or an ugliness related word, then to the left. If you see a dog and the cuteness related word, then to the right. And what we are interested at the end is to look at the average times you needed for the trial number 3 and for the trial number 5, because the trial number 3 was the trial for the congruent condition, where we assume that the cats are associated with cuteness and dogs with ugliness, and the trial number 5 is the opposite. We associate the cats with ugliness and dogs with cuteness. And what we have at the end, we have the milliseconds difference that will show which of the associations comes first in your mind. And knowing that the congruent condition holds, it means that you will need less time in order to associate cats with positive attributes with the cuteness, or dogs with negative attributes or the ugliness, as compared to the cats associated with ugliness and dogs associated with cuteness. But the problem with the milliseconds is that actually some people are just slower and some people are faster. And in order to have a kind of absolute value, you need to divide the value of each person through the standard deviation. And we have 2 types of D-score that we calculate. We have the Cohen's D and we have the D-score. It is more or less very similar data, but I think I don't want to be wrong, but I think the const is the value of the person divided by the standard deviation from all people, and the d-score is the value of the person divided by the standard deviation of the answers of this person. So both of them are standardized scores, but the one looks at the standardization within one person. So if somebody is slower, somebody is faster, and the average standardization, the overall making the results comparative. Usually we report both of the scores, but if you are required to report only one, then you usually report the d-score. So the score standardized for this specific person. And what we have the attributes and attributes and targets, how you can find them. Usually you can find pictures on the free sources such as Pixabay, or you can draw them on your own. For example, if you need pictures of male and female participant or targets, then you can probably find any picture somewhere online. They should be of the same size, so not that the one is very big and one is very small, so they should be more or less of the same size, and the picture of this person or this object should be also more or less of the same size. Not that you have the big picture with only a small object somewhere in the corner, and the next one is a big picture with a big object in the middle. You can also use GIMP and Photoshop to make them, and then you cut the pictures. I recommend to use the pictures of 300 pixels because you usually play or usually run this test on your computer, and the screens, you have to assume that the screens are small because not everybody has a large screen with 42 inch. Usually we have the screens with 17, 19, 23 inches. And in this event, having the pictures of the same size of 300 times 300 pixel is the optimal one. We also run, I will show you later in the later videos, two different tools with which you can run it, but mostly the 300 pixels holds for both of them. You save your picture as PNG or JPG, and take care that all pictures have the same size, because it doesn't matter will you run the tool number one, it is called free IIT, or will you use the Qualtrics. These pictures have to load, especially in the event of Qualtrics, because it is the test held online. And if you do it online, then better if all the pictures are of the same size, because they will be loaded also with the same duration. And the smaller the picture is also the better, because if you have a large picture with 1.5 megabytes, it will take really long that the picture will appear on the screen, and this will reduce the reliability of your results, because you will not measure the time of response, you will actually measure the time of loading the picture. That's why make them smaller. Usually try to make pictures about 5 to 10 kilobytes. Try to avoid the unclear pictures, for example, with several objects, as you see it now. Is it a dog? Yes, but it's not only a dog, it's also I don't know, a man or a woman sitting with a dog. It can be the sun, so that's why I try to be as precise as possible with your pictures. And if you look for the words, my recommendation is that you use the one core word. For example, if you are looking for ugliness, take the word ugly, go to thesaurus.com and look for the synonyms. And select the most popular synonyms, click on each synonym and go for the other synonyms. And also look for the antonyms in order to exclude those words that should not appear there, in order to reduce the problems. And I also recommend to try to avoid the words with the un, non, or in, for example, efficient, inefficient, because if you have the words like this, first of all, the words with the inefficient or non-efficient will be always longer. That's why you will measure not the response to the word itself, but to the length of the word, because the longer words will need more time to read them. That's why I try to keep all the words short, and they should be more or less of the same length. And a second, because this prefixes like un, non, and in, they will immediately indicate that it is a negative word, and you will immediately, without reading the whole word, understand a word, and you will understand that you have to sort it to the left or to the right, depending on what kind of task, what kind of trial you do now. And here are some examples. For example, for the trustworthy, accurate, authentic, believable, credible, honest. For the untrustworthy, you have the dishonest, doubtful, false, lying, deceitful. As you see, dishonest is not the best word because it has this at the beginning, but anyway, it's only one word, so probably would work. If you want to be sure whether your words work, you have to run the Friedman's rank test. In one of our papers, we did it. And it will show you whether the words are associated with a core word. In this test, you make a small survey where you say that here is the word that I would like to find, the trustworthiness. which of the words below do you associate with trustworthiness, and people have to rank them. And then you make the evaluation, you see whether some words are far away in the rank and some words are pretty close. If there are some words that are far away, you just take only those words which are related to the target concept mostly, and you just skip all other words. If it is not significantly different, if you don't find significant difference of the Friedman's rank test, actually it's also good. It means that all words are equally associated with the target word and you don't have to worry. If you want to refer to this paper, please let me know, or I'll try to post it in the description of this video below. And then, if you're not sure, make a pretest. And the next question is how many words, how many pictures you should use. There is no clear rule, at least not that I knew it. And I think it's good if you have about 5 to 10 pictures, and if you have 5 to 10 words for each target, for each attribute. Just because if you have too few, people will learn them and will not read through them. But if you have too many, it may be confusing. People will start reading through them, and actually it's pretty hard to find too many pictures and too many words. When we ran our study with the true and fake smiles, it took a while until we found sufficient number of pictures of a good quality that we could use, where people can easily understand what is the true smile, what is the fake smile. And the same with the words, sometimes very hard to find sufficient synonyms that everybody understands and associates them with the target concept. And I think that is all. In the next videos, if this video is interesting for you, I'll try to develop the notions on how to develop experiment on your own. I usually use the two tools. I use the one is the IAT tool for Qualtrics in combination with Qualtrics, and the second one is the offline tool that is called free IAT, free Implicit Association Test. As you can know from the name, it's freely available and you can run it in the lab. I'm also going to give you some comments about how to run it in the lab in order to save several data in one file. I hope it was helpful, and I just want to add a small thing that this test is usually very reliable. The criticism exists, but it's minor. And the good thing is that the sample size should not be too big, actually, as it is about the milliseconds of difference. You can find reliable results starting with 45 people for each group. So if you plan to test like 2 conditions, cats and dogs, I think with 80-90 people you can have already very strong results that you can already publish. The only thing you have to take care of is about the external validity. If you ask only about 80 people from one student's group of the same age from the same country, the results might not hold, because in a different country there will be a different stereotype. For example, if you go to Spain, you will see many more dogs than cats, and if you're in Austria, probably you will see more cats than dogs, and so on. So I may assume that in different countries there will be different stereotypes with regards to cats and dogs, and this implies that your sample should also include people from different countries of different ages, or you will have to restrict the generalizability of your test, and this will be just one of the limitations. Good luck with your research, and see you next time. Bye bye.